Welcome everyone to this session on relational algebra, one of the most fundamental concepts in database management systems. Relational algebra is a procedural query language that takes relations as input and produces relations as output, meaning it describes how to retrieve data step by step. There are two main categories of operations: unary operations, which work on a single relation, like selection, sigma, projection, and rename, row, and binary operations, which work on two relations, like union, set difference, ghatav, intersection, and Cartesian product, chi. Let's explore each one with examples. The selection operation, sigma, filters rows from a relation based on a given condition. For example, if we have a table named books with columns ID, subject, price, and year, then sigma subject equals database, books, will return only those rows where the subject is database. It's just like applying filters on an e-commerce website, narrowing results based on category or price. Next, the projection operation filters columns instead of rows. If we write subject, price, books, we'll get only subject and price columns, ignoring the rest. This is similar to showing just the name and phone number from a full contact list. Remember, projection removes duplicates automatically since relations are sets. Moving on to the Cartesian product, chi, it combines every row of one relation with every row of another. Suppose table A has columns name, age, sex, and table B has id and course. A chi B will pair each row of A with every row of B, creating all possible combinations. If A has n rows and B has m rows, the result will have n guna m rows. It's like pairing each student with every course before deciding who actually enrolled. The key difference between Cartesian product and join is that Cartesian product gives all combinations, while join applies a condition on top of it to keep only meaningful combinations. Hence, join equals Cartesian product jod condition. Now, let's see the union operation, which merges two relations and removes duplicates. For example, author, books, author, articles, gives all authors who wrote either a book, an article, or both. But remember, for union to be valid, two conditions must be met. 1. Both relations must have the same number of attributes, and 2. Their corresponding attributes must have compatible domains, that is, same data types. If these conditions aren't satisfied, the operation is invalid. Next is the intersection, which returns only common tuples between two relations. If borrow has customers Ria, John, and Alex, and depositor has John, Alex, and Meena, then their intersection gives John and Alex, the customers common to both. The set difference, ghatav, finds tuples present in one relation but not in the other. Using the same example, customerName, borrow, ghatav customerName, depositor, returns Ria, a customer who borrowed but didn't deposit. Then we have the rename operation, row, which assigns a name to the result of an operation. For example, row result, sigma subject equals, database, books, saves the filtered relation as result, just like saving a filtered Excel sheet under a new file name for reuse. Let's connect these to a real-life mini-project, a student result system. To find toppers in DBMS, you'd use sigma marks greater than 80 and subject equals, DBMS, result. To show only their names and roll numbers, use name, roll_no, result. To find students who topped in both DBMS and OS, use intersection, and to find those who passed DBMS but not OS, use set difference. In fact, every SQL filter, Excel query, or dashboard logic you use daily is rooted in these relational algebra operations. Now, let's test your understanding with a quick placement question. Suppose you have two tables, employee, name, dept ID, and department, dept ID, dept name, and you need the names of employees working in the CSE department. Which is correct? A. Sigma dept name equals CSE, employee chi department. B. Name, sigma dept name equals CSE, employee chi department. Or C. Dept ID, employee, dept ID, department. Think carefully, one gives extra data, one gives the exact result, and one is invalid. Comment your answer below ungli se niche ki or ishara. If this lecture helped you understand relational algebra and its practical importance, don't forget to dil like, clockwise arrows share, and speech balloon comment your answer or feedback. Keep learning, keep exploring, and remember, mastering relational algebra is the first step toward becoming a true database expert. Thank you for watching.